Okay, so to solve the equation x squared plus 2x equals -1, you move the 1 over, and you can either factor or do the quadratic formula. And then we were looking at this other equation, y plus 3 squared plus 2 times y plus 3 equals -1. And we said our intuition tells us to do this, to expand it and combine like terms. But if you stop and slow down, you would notice that the y plus 3 equation and the x equation are almost the same. They both are some stuff squared plus 2 times some stuff equals -1. So if I can solve one, I should be able to solve the other. So I solve the quadratic, the x squared plus 2x plus 1 equals 0. I get x equals -1, which means that my other equation if I did a bunch of fancy stuff, I would come up with y plus 3 equals -1. Which means that y is -4. So I can exploit the fact that this equation, this y plus 3 squared plus 2 times y plus 3 equals -1, is a quadratic that's very similar to an easier equation. Solve the easier one, then make a slight adjustment for the y plus 3. So in general, a generalized quadratic equation looks like a times some stuff squared plus b times some stuff plus c equals 0. So if I want to look at this equation, x squared plus 4x plus 5 squared minus 3 times x squared plus 4x plus 5 plus 2 equals 0, our intuition would be to square this piece right here, to actually multiply that out. Distribute the -3, combine like terms. But multiplying x squared plus 4x plus 5 times itself is like a nightmare. I mean, you could do it, but it just would take a lot of paper and patience. It's a little tedious. So I'm going to use the fact that this looks like a generalized quadratic. This is some stuff squared minus 3 times some stuff plus 2 equals 0. So instead of calling it stuff, right, I'm going to give it a letter name. Something other than x, because x is already being used. So pick any other letter you want. Z. Okay, so z squared minus 3z plus 2 equals 0. So I'm replacing x squared plus 4x plus 5 with z. In my original equation, I replaced all the x squared plus 4x plus 5s with z's. Now, this is not a very difficult equation to solve. This one with the z's in it, because it factors. This would be z minus 2 times z plus 1. Sorry, minus. So z equals 2 or z equals 1. But the question asked me to solve for x. I want to figure out what x is. So once I know what z is, what my stuff is equal to, I go back to this replacement equation that I had, plug in the numbers for z, make z a 2 and make z 1 and find out what the x's are. So if I replace this z with a 2, that gives me that x squared plus 4x plus 3 equals 0. So I subtracted 2 from both sides. So then that factors to x plus 3 times x plus 1. So x equals -3 or x equals -1. So it's 2 solutions, but I still have to replace z I replaced z with a 2, but now I have to replace z with a 1, right? Because z is either 2 or 1. So in my equation, x squared plus 4x plus 5 equals z, replace z with a 1, and I want to solve this guy now. Subtract 1 from both sides. X squared plus 4x plus 4 factors to x plus 2 times x plus 2. So x equals -2. So those are my three solutions. -3, -1, and -2. It depends on the context. So sometimes you can eliminate one because it's impossible. Like if you're trying to find a distance and something comes out negative, you can eliminate that one. Right. So in this one, there is no context, so they're all solutions. Yeah, it's extraneous solutions happen when you can eliminate one based on the context. But let me show you a nifty way of checking your answers on your graphing calculator. Okay, so in my graphing calculator, I want to put the original equation. This thing right here. So in y1, I'm going to put the whole left side of the equation. X squared plus 4x plus 5 squared minus 3 times x squared plus 4x plus 5 plus 2. So one feature of your calculator that I've not yet shown you is the table, which is second graph. So if you press second and then the graph button, you get a table. And I can plug x values in here and get the y values out. So what I should be able to do is when I plug the solutions in for x into this equation, what should I get for a y value? 0. Yeah, should get the other side of the equation. So if I plug in -3 for x, my y1 is 0, so I know I did it right. I know the equation's true. -2 and -1. Okay, so who can't type in x values? Anybody? Okay, so if you can't type in the x values, go to table set right above window, second window. Change the independent variable to ask. So independent is ask and dependent is auto. Okay, so that's the generalized quadratic. To move on to polynomial equations, sometimes the only recourse we have right now is if we can factor it. If the degree is higher than 2, right, if it's not x squared but x cubed or x to the 4th, the only thing we can do is try to factor it. So in this case, x to the 4th plus x cubed minus 6x squared, can that be factored? what can how do I factor it? Take out x squared. Great. So this becomes x squared plus x minus 6 equals 0. So then the x squared plus x minus 6, that can be factored even further. So I have x squared times x plus 3, x minus 2. So now I'm multiplying 3 things together, and the answer is 0. So the same property applies, the zero product property. If you multiply things together and the answer is 0, at least one of them has to be 0. So either x squared is 0, or x plus 3 is 0, or x minus 2 is 0. So if x squared is 0, that means that x is 0. X is negative 3, or x is 2. So for polynomial equations, all you can do is try to factor it and make it look like something you know how to do. That's going to be kind of a common theme in this course. Whenever you see a new kind of equation, try to make it into something that you know how to do. So here's another example of that. Now I have an equation with square root in it. We want to try to turn whatever type of equation we have into something we already know how to do, whether it's linear or quadratic or a polynomial. What do you want to do? Square everything. Okay. So x plus square root x squared, that's x plus square root x times x plus square root x equals 144. And then to multiply these together, I get x squared plus 2x root x. And what's root x times root x? X. Okay. So what was the purpose of the squaring everything? It was a good suggestion. Why did you have that thought? To get rid of the root. Oh. There's still a root in there. Shoot. There's still going to be a root. There's going to be at least one root in there if you do it again. Because multiplying this thing, right, times itself is going to give a lot of terms, and some of them are going to have roots in them. Combine x plus root x.
Well, find a way of doing that.
Yeah, you can't add those because they're not like terms. But no, you can't make them like terms, but we could separate them. How could you get x away from root x? Subtract from one side. So let's see. This we decided was not going to help us too much, but if I subtract x from both sides, subtract x from both sides, get that x away from the root. Now I can square both sides, and the root is going to go away. So root x squared is x. And 12 minus x times 12 minus x, you have to FOIL out, and you get 144 minus 24x plus x squared. And then, can you solve that thing? Yeah, that's a quadratic. You know how to solve that. So that just simplifies to x squared minus 25x plus 144 equals 0. And use the quadratic formula. So we had to do a small manipulation. I subtracted x from both sides. So I had a minus 24 take 1 away, and you have minus 25. So do whatever manipulation it takes to turn the thing you don't know how to do into something you do know how to do. So in this case, my A is going to be 1, B is negative 25, and C is 144. So I'm going to have my calculator do most of the calculations so that I don't make a mistake. So I need negative B, so that's 25, the opposite of B, plus or minus, so I'm going to start with just writing a plus. The square root of B squared, and I just wrote in positive 25 squared because 25 squared and negative 25 squared give the same value. So I just always write the positive. So B squared minus 4 times A times C. And I get 32. And then that's all over 2A. Yeah, so over 2 times 1, 16. So then I have to do the same thing, but with minusing, because it has to be plus or minus. So I'm going to do second entry, get the previous thing I wrote in back, minus. And this time I get 18 over 2A, which is 9. So I get 16 or 9. Now, I'm glad that you asked me to finish this question. X equals 16 or 9. Let's check it in the graphing calculator. We'll do the little table method that I showed you. So I'm going to type in x plus square root x in y1, and y2 I'll put in 12. When I go to my table, when I type in what I got as solutions, which were 16 and 9, what should happen when I plug a 9 into the original equation for x, when I plug a solution in here, the left side should equal the right side, right? That's what it means to be a solution. So if I'm using my calculator to do that for me, when I plug 16 or 9 into the calculator for x, my y1 and my y2 should be the same. So it looks like 9 is a solution, but 16 is not. Doesn't? Do they both say 12? Is that what you have in y1? X plus square root x? It does? Let's see. 4 and 16 plus 4 is 20, not 12. No, it's not. The square root of 16 is 4, not plus or minus 4. Yeah. Square roots have just one answer. When you take the square root of a number, it's just the positive value. Square root of 16 is 4, square root of 25 is 5. So if you're just taking the square root of something, it's the positive answer. This is a really, so square root of 16 is 4. The thing we do plus or minus on is when I say that, is when I'm solving that equation. I take the square root of both sides, and I actually get 4, but I have to also know that negative 4 works. I know. So it did turn out that 16 was not a solution. Right, so if you go to the original equation, plug a 16 in here, 16 plus the square root of 16, that's 16 plus 4 is 20, not 12. Okay, so 16 is not a solution to this equation, but 9 is. 9 plus 3, 9 plus the square root of 9 is 12. So this is what we call an extraneous solution. So like you were asking me about earlier, sometimes you get extraneous solutions from the context of a problem, and you cross something out that, oh, that can't be. Sometimes you do everything right, all the algebra is correct, and you still end up with an extraneous solution. So you always have to check your answers. Yes?
Would there ever be a case where either of those?
I don't think so. All right, so let's talk about absolute value, and then that'll help clear up the plus or minus thing. So the formal definition of absolute value of a number is if you take the absolute value of A, it's A if A is bigger than or equal to 0, and the opposite A if A is less than 0. So this is sort of the formal, very mathy definition of absolute value. Because our sort of colloquial definition, our typical definition is positive, right? Just take whatever's in there and make it positive. If it's already positive, it stays positive, and it's negative, you make it positive. So does this formal definition jive with what you know about absolute value? So this is saying if A is positive, then you keep the number the same. So you're taking the absolute value of A, and A is positive, the absolute value of A is A itself. That jives, right? That's what we know. And this part says if A is negative, you take the opposite of it. So if A was negative 5, the absolute value would be the opposite of negative 5, which is 5, right? So this is saying in our really super mathematical notation what we think of as absolute value. Okay. It says if A is negative, you take the opposite, that is make it positive. And if A is positive, you leave it alone. So for absolute value equations, I want to solve, say, the absolute value of x equals 5. So I want to find all the numbers on a number line that have a distance 5 units from 0. So that's another way we talk about absolute value, is distance from 0. So what two numbers on the number line are 5 units from 0? 5 and negative 5. So there are two solutions to the equation absolute value of x equals 5. And in general, if you have the absolute value of some stuff equals a number, you have to write two equations down. Either your stuff is just equal to that number, or your stuff is equal to the opposite of that number. So, to summarize, to solve an absolute value equation, create two equations and solve them both. So say I asked you to solve absolute value of x minus 2 equals 3. So I have to write two equations. X minus 2 is either 3, right? Or x minus 2 is negative 3. The absolute value of some stuff equals a number. Either your stuff equals that number, or your stuff equals the opposite of that number. And then you solve them both. X equals 5, and x equals negative 1. Check both your solutions. If I plug a 5 in here for x, 5 minus 2 is 3. The absolute value of 3 is 3. That one checks. For the -1, take the absolute value of -1 minus 2. That's the absolute value of -3, which is 3. Check. So both solutions are correct. So before I do this one, let's look at this equation again. X squared equals 16. To undo the square, I square root both sides. The square root of x squared is the absolute value of x. Square root of 16 is 4. So now I have an absolute value equation, which means I have two equations, x equals 4 or x equals -4. So that's where the plus or minus comes from. We just do this so often that we usually skip the absolute value step. We write the square root, and then we just say x equals plus or minus 4. But when we skip that, when we go right from here to here, you have to keep in mind that you're skipping this step of the absolute value of x. What's not the same answer? That the absolute value of x equals 4 and x equals plus or minus 4? They do mean the same thing, yeah. So let's say I have another absolute value of equation. The absolute value of 2x plus 1 equals 11. You guys solve this. Okay, so let's see what we came up with here. We have some stuff. The absolute value of some stuff equals a number. So either your stuff equals 11 or your stuff equals -11. Two equations go with every absolute value. So this one ends up with x equals 5. And this one ends up with x equals -6. Check them both. Nope. Because if I plug a 6 in here, 2 times 6 is 12, plus 1 is 13. Absolute value of 13 is not 11. But if I plug a -6 in, 2 times -6 is -12, plus 1 is -11. In absolute value is +11. 2 times -6 plus 1, that's... So that one works, the -6. And then this one works because absolute value of 2 times 5 plus 1 is the absolute value of 11, which is 11. All right, so if you're given something more complicated looking, make it look simple before you try to solve it, right? So I have 2 times the absolute value of x minus 3 equals 5. First, make it look like the absolute value of some stuff equals a number, because you know how to do that. You know how to solve that. So first, I'm going to add 3 to both sides. So I get 2 absolute value of x equals 8. Then what should I do? Divide by 2, so I get absolute value of x is 4. And then what are my two equations? Yep. I manipulated it until it looked like the absolute value of some stuff equals a number. Then I write my two equations. X equals 4, x equals -4. Okay, you do this one. Okay, so I have one table who's calling me mean. So I'm gonna stop you before you work too hard. Step one, I need to make this look like the absolute value of some stuff equals a number, because I know how to do that. So I'm going to subtract 8 from both sides. I get the absolute value of 3x minus 7 equals negative 6. Why should I stop now? Yeah, Michael. Yeah, the absolute value of anything can never be negative. I tricked you. Really? Let's see. So if I do 3x minus 7 equals 6, or 3x minus 7 equals negative 6, here I get x equals 13 thirds, and here I get x equals 1/3. So let's see what happens if I plug these values in. Okay, so 3 times 13 thirds minus 7 is 6, plus 8 is not 2, right? So when I plug 13 thirds in here, I get the absolute value of 6, which is 6, plus 8, which is not 2. So 13 thirds doesn't work. If I do 1/3, 3 times 1/3 minus 7, in absolute value, that would be 6, positive 6, plus 8 is 14, not 2. So neither of them work. So let's see, 3 times 13 thirds is 13. So this is 6 plus 8, which is not 2. And then over here, if I plug in a third, I get the absolute value of 3 times 1/3. Does that equal 2? Well, 3 times a third is 1. The absolute value of negative 6 is 6 plus 8, which is not 2. So neither of the solutions end up being correct. So actually, somebody asked me if there's ever an instance where you get 2 extraneous solutions, so I guess this would be one. Because what we did is actually not legal. You can't, this equation is not equivalent to these two, because the absolute value of anything can never be negative. So this has no solutions. There are no numbers that will make this true. All right, we're going to stop there.